Hi, good morning. Online people, please confirm my voice is audible.
GCP.
Thank you. So actually, as part of yesterday's session, we discussed about BigQuery architecture. Sorry. So yesterday we discussed about the BigQuery architecture. So as part of BigQuery architecture, we are having storage layer separately, and we are having compute layer separately. And to maintain the communication, both the things, we are having the network. And whatever the storage layer we are having, the storage layer we can able to call it as a Colossus. And whatever the compute layer we are having, that compute layer we are calling it as a Dremel. And whatever the network we are using, that network only we are calling it as a Jupyter. Okay, so yesterday we discussed about all these topics, Sandy. What is the Colossus, what is the Dremel, what is the Jupyter, what is the bar? All this kind of information we discussed as part of our yesterday's session. So in this, what is the storage layer? Colossus is a storage layer. And what is the compute layer? Dremel is a compute layer. And where we are maintaining the communication by using a network, by using the Jupyter, we are maintaining the communication. And with the help of the Borg, what is going to happen? It is going to perform the orchestration. All these are the different components we are having as part of our BigQuery architecture. Okay. And one more thing, just want to inform you here. Actually, it's looking like a kind of a tree structure. And if you see here, it's a kind of a tree structure. In this tree structure, what all are the leaves? We can able to say leaf nodes are going to act as a leaves and mixers are going to act as a branches. So that's the way simply we can able to call it as a tree structure. If you are going to see in the Google somewhere, they will mention that BigQuery is going to act as a kind of a tree structure. That's the reason. Just I'm putting the statement. Our BigQuery architecture is a kind of a tree structure. In this tree, what are the leaves? All the leaf nodes we can able to call it as a leaves. And what are the branches? Mixers we can able to call it as a branches. But here we can able to say simply in the BigQuery architecture, we are having the compute layer, which we are calling it as a Dremel, and we are having a network, which we can call it as a Jupyter, and we are having the storage layer, which we can able to call it as a Colossus. Now tell me, what all are the features of the Colossus as we discussed yesterday?
To store.
Features of Colossus. First one, definitely to store the data. What else? It will provide what?
Replication.
Replication automatically. Third one, data will distributed in the distributed manner, or we can able to call it as a data distributing in the parallel way. Okay, so these are the some of the features of the Colossus. In the same way, here we need to understand one more important thing that we are going to discuss in the today's session. Colossus is going to maintain all the data in columnar format. So what is happening here? In the Colossus, all the data is going to maintain in the columnar format. And one more thing we need to understand here. Colossus is a kind of a file system which is handling by using capacitor. See, in the Colossus, it is going to store all the data, but how it is storing all the data with the help of the capacitor. This is the one, just a new word we need to understand. So nothing more to discuss about the capacitor. And the Colossus is a kind of a file system. In this file system, all the data is storing with the help of the capacitor. And one more important thing we need to understand here, all the data is storing in the columnar format. Now here mainly we need to focus about what is meant by columnar format. Okay, so to understand this, first we need to understand whenever we are going to store the data, that data can store either in row format or second type of format of data, we can call it as a columnar format data. So what is going to happen whenever we are going to store the data, that data can store either in the row format data, or that data can able to store in the columnar format of data. So first we'll try to understand what is meant by row format data, what is meant by columnar format data. Then we'll try to understand in what kind of databases or in what kind of systems we are having the row format data, and in what kind of systems we are having the columnar format data. So first we'll try to understand what is row format data, and then we'll try to understand the what is the columnar format data. You try to give the answer as per your knowledge. Any guesses what is meant by row format data?
Rows are distributed in row level. Sorry, data is distributed in row level.
Data is distributed in the row level. Okay. Then what is meant by columnar format?
It will be loaded or retrieved through by using the columns only.
Okay, so partially correct, Andy. So we'll see one example. By seeing the example, you can able to easily understand what is the row format data and what is the columnar format data. Just we'll see one example quickly. Now see, for example, we are having the employee table. In this employee table, I am trying to load total 3 records. I am loading the 1, 2, 3, and e-name values are ABC, DID as a 10, 10, 20, and salary values as a 1000, 2000, 3000. Now, for example, whenever we are going to say data is storing in the row format, or whenever I'm going to say my database is maintaining all the data in the row format, then what will happen here is your data will store like this. So it is taking first record. Just for understanding, just I'm giving a color coding only. So this entire row is nothing but this is the first record. And coming to second record, what will happen is it will start at the end of the last column. So this is the second record, and this is the third record. So internally, what is happening here? Your data is storing like this, Andy. So it is storing the first record. It is storing EID, e-name, DID, and salary. Again, just for your understanding, I will mention this also. So what is happening? It is storing EID, e-name, DID, salary. It is storing all the values. After completion of the last column, then what is happening? Again, it is trying to store the second record. In the second record, after completion of the last column, again it is trying to load the data for the third record. Just for our understanding. To understand what is the last column, I'm giving the red color only. Now, actually here, what is happening? All the 3 rows are storing like this. This is the first row, and after completion of the last column, it is taken the second row. After completion of the last column, again it is taken the third row. This is the way your data is storing as part of your row formatted data. This is the way your data is storing as part of your row format data. Now, for example, my requirement is here. I want to fetch data for salary column. For example, internally what I'm telling, whenever it is going to maintain the row format data, internally your data is storing like this, and your data is storing first record. After completion of the last column, it is taking the second record, and after completion of the last column, it is taking the third record. Now, internally your data is storing like this. Now, after storing the data, for example, here my requirement is I want to fetch data for particular column called as a salary column. For example, here I have written the query like this: select sum of sal as total sal from EMP table. So what I'm doing here, I want to perform the sum operation. On which column I want to perform the sum operation? I want to perform the sum operation on top of your salary column. Earlier what we discussed, all these queries are executing on top of your table. Indirectly what it means, where we are having the data, in your internal database system, you are having the data. For example, in the internal database system, it is maintaining all the data in the row format only. Now, if your data is maintaining in the row format, on top of this row format data, for example, I am writing the query called as a select sum of salary from the employee table. Now, you try to give the answer, how it can able to fetch the data from the row format data. Any guesses? Is it directly going to the salary column, or it will try to fetch all the 3 rows? After fetching all the 3 rows, then it will fetch the salary column. Any guesses?
First, it will fetches the data, total data.
Whether
then
it will fetch all the rows, then it will fetch
check for
salary column data. Will it is going to happen like this, or directly it will fetch data for salary column and perform operations? So which scenario is going to happen? Here I'm given the two statements, and when I'm going to execute this query, whether it will fetch all the rows from the table, then it is going to pick the data for the salary column. This is the way it will execute, or directly it is going to fetch the salary column from the table and it is going to perform the operation. What is the thing going to happen?
First one.
Will fetch all the rows.
See here what will happen is it will take the first operation, and because here how we are having the data, you are having the data for the first row, then you are having data for the second row, then you are having data for the third row. In this situation, if you want to fetch data for salary column, what need to happen? It need to read all the records, and which is nothing but it is going to read all the 9 records or all the 3 rows here. From after reading all the 3 rows, what will happen? Then it is taken the salary value from the first row, then it is taken the salary value from the second row, then it is taken the salary value from the third row. This is the way it is going to perform the operation. But tell me, as per your requirement, you want to read all the columns and all the records, or you want to read only salary column? I want to read only salary column, but unnecessarily what is happening here, because of having the row format data as part of execution of this query, it is taking the data for all the rows, all the columns. Then it is taking the data for the salary column. With that, you are going to get the output. Indirectly, what we can able to say here? So here we can able to say this operation will happen for row format data, and because of this, it need to handle more records and more columns. So what I'm telling here, because of this reason, what is going to happen? It need to read all the records. From all the records, it need to read all the columns. Then it will perform required operations on required column. Just for our convenience, I will copy this to the notepad. What I'm telling here, so whenever we are going to deal with the row format data, what is going to happen? It will fetch all the rows, then it will fetch the salary column as part of our example. So here simply we can able to say this is yes. But what is the problem here? Because of this operation, it will happen on the row format data. Because of this, what is happening? It need to handle more records and it need to handle more columns. Then it is going to perform the required operation on top of your required column. Now tell me, because of this reason, your performance is fast or performance is slow? Because of this reason,
Performance is slow.
performance is fast or slow?
Slow.
So we can able to say here our performance is slow, because as per my requirement, I want to deal with the only salary column. But whenever it is going to maintain the data in the row format, what is happening here? It need to read all the rows, it need to read all the columns. After that, it is trying to fetch data for the salary column. Because of doing these many operations, automatically what we can able to say, as part of row format data, we can able to see performance is slow. Okay. Now see, for example, here I'm given the query called as select sum of sal from employee table. When we are discussing about this example, or when we are discussing about this query, we are saying that performance is slow. Now, for example, my requirement is, I am writing the query like this: select star from employee table. Now tell me, if I am going to run this query, now performance is fast or performance is slow? This is one example on top of our row format data. We discussed that I want to get data for only salary column, but because of row format data, it is going to read all the rows, all the columns. After that, it is fetching the data from the salary column. Then it is going to perform the sum operation. Because of all these operations, what is happening here? Your performance is slow. But if you see the second query, here are we performing any specific operation on a particular column?
No, sir.
No, right? What I'm giving here, I'm giving it as a star.
Star.
What is the meaning of star? You want to get data for all the columns of all the records. And now in this situation, if you are going to maintain the row format data, performance is slow or performance is fast?
Fast.
In this query, I can able to say, because of using row format data, we can able to say performance is fast. Okay. Now I am only giving the two different statements, and in the row format, data, your performance is slow. I am only telling that in the row format data, performance is fast. But how it is possible? One scenario we are telling it is a slow operation. One scenario we are calling it is a kind of a fast operation. Then how we can able to say when we need to go for row format data? By seeing these two examples, you try to give the answer. In what type of scenarios we need to go for the row format related data?
If we want to fetch all the data from the table.
Yes. So, or we can able to say if you don't want to perform any kind of operations
Yes.
on specific columns,
Specific column. Yes.
then we can go for
Row
format data. So what I can able to say here, if you don't want to perform any specific operation on top of any particular columns only, in the situation, what we can do, simply we can able to go for the row format data. Now you try to give the answer. In what kind of projects we are going to perform this kind of aggregate operations? Earlier we discussed already. You try to give the answer. In what kind of projects mostly we are going to perform kind of aggregate operations?
Analysis purpose.
We can able to say in data warehousing projects. For what reason? Earlier we discussed, right? Whenever you want to perform any kind of analysis, we need to maintain the summarized data, or we need to maintain the detailed data. We need to maintain the kind of the summarized data. What is the meaning of summarized data? And we are going to perform the sum operations, or we are going to perform the count operations. Whenever we are performing these kind of aggregate operations, that kind of data we can call it as a summarized data. Why we are using the summarized data? For the purpose of doing analysis. In which kind of projects we are doing this kind of analysis? In the data warehousing projects, we are going to perform this kind of analysis. And now you tell me, if you are going to build the data warehouse system, if we are going to build data warehouse system in such kind of projects, if we are using row format data, are we going to get good performance or bad performance?
Bad performance.
Obviously, we can able to say we are going to get the bad performance. What is the reason? You are going to work in the kind of the projects called as nothing but our. So we are going to work in the kind of the projects called as a data warehouse system projects. In the data warehouse projects, we are going to perform the kind of aggregate operations, or we are going to deal with the summarized data. Whenever you are going to deal with the summarized data, we need to deal with the specific columns on top of the table. So if you are going to deal with the specific columns on top of the table, as per the previous examples, we mentioned that our performance is bad whenever we are going to deal with the specific columns of the table as part of your row format data. That's the reason in the data warehousing projects, we can able to say if we are going to deal with the row format data, what is going to happen? It is going to provide the bad performance. Okay. Now tell me, to overcome this kind of issues, what kind of data we need to use?
Columnar.
We are going to use columnar format data.
So here row level also we are using some indexes, right? So it will get some fasting.
No, even if you are going to use the indexes also, what is going to happen? You are going to deal with the complete row, or you are dealing with the only specific column?
If we are going to compare with the primary keys or indexes, means directly it will fetch that particular data only, right?
Yeah, particular data. But so for example, it is fetching the particular data, but in this particular data, again, you need to fetch data for all the columns, or you are directly going to fetch data for the only salary column. Your index is going to helpful to fetch the particular rows, that I can understand.
Yeah.
But in this row, it need to deal with all the columns, then it need to deal with the salary column, or directly it is going to deal with the salary column.
Yeah, it should compare every row.
It need to take complete row.
Total.
After taking the complete row, it need to take the salary column. So like this, it need to perform the operations on the complete row. Because of that reason, what is going to happen? It is taking the more amount of time compared to our columnar data store.
Okay.
Okay. Yeah. Now, to overcome these kind of issues, what we are doing here, we are going to use the columnar format data. Before going to that, first we'll try to understand what is meant by columnar format data only. And before that, just I want to explain one more thing. Now, for example, in this table, I am inserting one more record. Just 1 second, I will save this document. Now, for example, here, I am trying to insert one more record like this, 4D 24,000. Okay, so now for example, this is the new record we are inserting. Now you tell me in the row format data where this record is going to store.
At the
If we are
end,
dealing with the row format data, what is going to happen as we discussed earlier? Every row, how it is inserting, this is the first record. After the last column, it is taking the second record. After the last column, it is taking the third record. Now, if you are going to insert the fourth record, what is going to happen? This record again will be inserting after the last column of the previous record. And so this is the way your data is inserting on top of your row format table. Now, by seeing this example, you try to give the answer. Whenever we are dealing with the row format data, loading operation is fast or slow? I'm asking about the loading operation, not the fetching operation. And I am talking about the loading operation. What is going to happen? Just this record is loading at the end of the record only, which is nothing but after completion of the first row, it is loading the second record. After completion of the second row, it is loading the third record. After completion of third row, it is loading the fourth record, which is nothing but whenever you are going to perform the loading operations, we can able to say in the row format data, it is going to perform the very fast operations. Okay, but what about the fetching?
fetching is slow.
Fetching column data. As we discussed earlier, what we can able to say here, to fetch the data, it is going to perform the slow operation. Now, indirectly, you try to give the answer. What is the advantage of the row format data? What are where we can able to see the advantages by using the row format data? As part of data loading operations, we can able to see data loading is happening very fastly on the row format data. But what is the disadvantage, Andy? Whenever you want to fetch the particular column data, there we can able to see the disadvantage because it need to read all the rows, it need to read all the columns. After that, it need to read the data for a specific column. Because of that reason, what we can able to say, whenever you are trying to data for particular column, we can able to see the slow operation. But as part of data loading, what is happening here? It is providing the fast operation. This is the advantage on top of the row format data. So here I will add, this is advantage, this is disadvantage. Okay, now we'll try to understand what is happening on top of your column format data here. Okay, now see what will happen is, as part of column format data, instead of loading the data or instead of storing the data at the row level, it is going to store all the data at the column level. And what is the meaning of column level? Try to understand. I will remove this record first. It is going to take the values as 1, 2, 3. Now see here, all these records are falling into the single row or it's falling into the single column. It is loading all the values like this, 1, 2, 3. This whole data is for which column? This is for employee ID column. Okay. After that, it is going to store data for employee name, after that, it is going to store data for department ID. After that, it is going to store data for salary values. Okay. Now tell me, what is the difference between the previous example and this example? Or what is the difference between the row format data and column format data? In the row format data, what is happening? It is storing one row with all columns. After that, it is storing the one more row with all the columns. After that, it is storing the third row with all the columns. And but comment here, what is happening? It is storing all the column values together in the employee ID. It is storing all the ename values together. It is storing all the department ID values together. It is storing all the salary values together, which is nothing but it is storing all the rows together, or it is storing the data for the columns together. It is storing the data for the column values together. And so whenever data is storing like this, that kind of data only we can able to call it as a columnar format data. Here, your data is storing together at the column level. But coming to previous example, your data is storing together at the row level. But here, your data is storing together at the column level. Here, it is taking all employee ID values together, one column, ename values together, second column, DID values together, third column, salary values together, fourth column. This is the way at the column level your data is storing together. Now, for example, our data is storing like this in the columnar format. Now, for example, I'm going to run this query here. Now, tell me how this query is going to execute. What will happen? It will read all the rows, or directly it will go to the salary column. directly it will go to the salary column. What is the reason? Because your data is storing together at the column level. And here on which column you want to perform the operation? I want to perform the operation on the salary column. That's the reason. As part of execution of this query, what will happen? Directly it will go to the salary column. Now tell me, we are having the salary values at the multiple places, or we are having all the salary values together here? We are having all the salary values together as part of your columnar format data. That's the reason whenever we are going to execute this query, what will happen? It will directly go to the specific column, whatever we are having in the internal database system. On top of this, it is going to perform the sum operation. Now you tell me, in the columnar format data, this query is going to provide the best performance or bad performance? This is going to provide the best performance. What is the reason? Because all salary values are stored together in columnar format data. All the salary values are stored together as part of our columnar format data. For that reason, when I am going to perform these kind of aggregate operations on a specific column, then what is happening? Automatically we can able to see the very good performance. But tell me, for example, I am going to run the query like this. Select star from EMP table. Now tell me, this query will give the best performance or bad performance? I am given the select star from the table. What is the meaning of star? It need to fetch data for all the columns. Now what need to happen? It need to go here. It need to take the EAD value. It need to go here. It need to take the ename value and DAD value from here and salary value from here. That is for first row. Now what about the second row? Again, it need to fetch the second value, here also second value, here also second value, here also second value, because I want to get data for all the columns because I'm given the star operator. Now, whenever we are going to deal with the column format data, if we are going to give the queries like this, now we are going to get the good performance or bad performance?
Bad performance.
Automatically, we can able to say it is going to provide the bad performance because we need to fetch data for all the columns, for all the records. But in the above example, I want to fetch data for only salary column. On top of the salary column only, I want to perform the sum operation. In that situation, columnar format data is providing the best performance. But whenever you want to deal with the complete data for complete columns, then what is going to happen? You are going to get the bad performance. That's the reason here we need to understand, whenever you want to perform kind of aggregate operations, then columnar format data is providing the best performance. Whenever you want to deal with the normal kind of data, then columnar format data will not provide the best performance. Okay. Now this we are talking from the fetching perspective. While fetching the data to do aggregate operations, here we can able to say we are seeing the best performance. Okay. Now you try to give the answer here as part of loading the data. I'm asking loading the data, not for execution of the query. Here my question is, as part of loading the data, how columnar format data is going to work in the internal system? For example, I am trying to insert this record. First, try to give the answer how this record will insert on top of your existing data in the internal database system. This is the existing data, right? Now tell me how this data is going to insert for the fourth record.
Here again one more cell. Take one
extra
more
column.
What will happen? Here it will take the one more cell. It is taken the value as a 4. Okay. Now in the same way,
you have to add one more cell.
Here also it will take it as a D, for example. In the same way, now tell me, in the Excel only, if you want to type all this information, it is taking good amount of time only. Now in the internal database system also, what need to happen? On top of employee ID column, beside the employee ID values, it need to insert one record. Beside the employee name existing values, it need to insert one more record. Beside DAD values, it need to insert one more record. Beside the salary column values, it need to insert one more record. But in the row format, what is happening? Directly complete row is appending to our last row. But coming to here, for every column, it need to adjust the EAD column. It need to adjust the ename column, it need to adjust the DAD column, it need to adjust the salary column. Now you tell me, in the columnar format data, as part of loading the data, it is going to provide the best performance or bad performance?
Bad performance.
Simply we can able to say it is providing the bad performance only, because as part of columnar format data, whenever we are inserting a row, what is going to happen? Every column value need to append for each and every individual column. In this example, 4 is appending to the EAD, D is appending to the E-name, and 20 is appending to DID, and 4,000 is going to append to the salary column. For the purpose of appending the data to the each and every individual column, what is going to happen? It will take more time. But in the row format data, what is happening here? Whatever the row we are inserting, that row is appending at the end of the table or at the end of the system in the
Last
internal database system. That's the reason, as part of row format data, loading operation is very fast, but fetching operation is slow. But coming to columnar format, what is we are saying here? Loading operation is slow, but fetching operation is very fast. And these are the things we need to understand on top of our row format data and columnar format data. Okay, now you try to give the answer here. In the columnar format, what is the advantage? We can able to say simply fetching data based on a specific column is fast. Disadvantage, we can able to say
Loading data.
loading data will take more amount of time compared to row format data. Okay, now in the same way, if I want to add the advantages and disadvantages here, loading data will take less time compared to columnar format data, and fetching data based on a specific column is slow here. So like this, if you observe here, on top of row format data, we are having some kind of advantages and disadvantages, and on top of columnar format also, we are going to have some kind of advantages and disadvantages. And we cannot able to say every time we need to go for row format data, every time we need to go for the columnar format data. But depending on the type of the project which we are working, sometimes we are going for the columnar format data. By depending on the type of data which we are dealing, then what we are doing here, we are going to deal with the row format data. Now, why we are discussing all these things? Because we are discussing about the BigQuery. Within the BigQuery, where our data is storing, and our whole data is storing into the Colossus. As part of storing the data into the Colossus, it is going to use a file system called as a capacitor. And here it is going to store all the data into the columnar format. Okay, to understand this, we are discussing about what is the row format data and what is the columnar format data. And now overall, in BigQuery, what kind of data it is storing internally? You are inserting the rows only, but internally how it is storing? It is storing all the data into the columnar format. Again, this is the one of the interview question. And in the BigQuery, what type of data it is storing in the internal system, or what kind of format of data it is going to maintain internally? So what we can able to say here, in the BigQuery, it is going to maintain the data in the columnar format. Or when they are asking about the BigQuery, earlier we discussed about the multiple features of the BigQuery, and like high scalability and high availability and multi-cloud, like that we discussed about multiple features. Other than all those features, we can able to add the one more feature. What is that? BigQuery is going to store the data in the columnar format. For that reason, as part of doing the aggregate operations, it is providing the best performance. And we discuss one more statement. BigQuery is what in the simple words? BigQuery is what in the very simple words?
Data
is a cloud data warehouse. Few minutes back we discussed, Randy, in the data warehouse, what activity we are going to perform? Analysis. If you want to perform analysis, you are going to maintain the summarized data or detailed data. We need to maintain the summarized data. Now, how we can able to get the summarized data? By performing summary operations. Now, to perform the summary operations, your columnar data is going to provide the best performance, or row format data is going to provide the best performance? Obviously, our columnar format data is providing best performance to do summary operations on the data. That's the reason simply we can able to say in the BigQuery, in the internal system, what is the type of data it is maintaining, and it is maintained in the columnar format. And BigQuery is a kind of a data warehouse system. In the data warehouse system, if you want to perform the analysis, we are going to maintain the summarized data. To get the summarized data, columnar format is going to provide the best performance. That's the reason nowadays most of the companies are migrating to the BigQuery data warehouse. Okay. Now, based on your understanding, try to give the answer. Is there any other columnar format databases or systems are available in the market? Any idea? So just now we discussed about BigQuery only. Other than BigQuery, do we have anything? We have Redshift and we have Snowflake. So like this, we are having some other databases or some other data warehouses where it is supporting the columnar format. BigQuery storing the data in the columnar format. Redshift storing the data in the columnar format. Snowflake storing the data in the columnar format. Indirectly, all these are going to provide the best performance as part of our data warehousing projects. Okay. Now, what about the row format related databases? Any guesses? Row format databases.
All the databases.
MySQL is a row format database. And Postgres is a row format database. Teradata is a kind of a row format database. And we can able to say SQL Server is a kind of a row format database. And Oracle is a kind of a row format database. All these databases are nothing but internally data is storing in the row format. But coming to here, BigQuery or Redshift or Snowflake, and your data is going to store in the columnar format. For that reason, compared to these databases, here we can able to see the best performance as part of our data warehousing projects. Okay. Now I want to give the pause for 1 or 2 minutes, and if you have any questions up to here, please ask me.
Sir, one question, sir.
Yes, please.
Regarding SharePoint online or SharePoint workflow, they also store the data in the columnar format, sir, internally, even though it uses SQL Server. So can I consider it as a resource description format or data warehouse system?
See, whenever we are going to maintain the data in the columnar format, can we be able to call the system as a data warehouse? No, right? See, here we are discussing in the data warehousing projects, we are going to perform the summary operations. To perform the summary operations, better to maintain the data in the columnar format. So with the columnar format data, we can able to get the best performance. Okay. Now, wherever we are going to maintain the data in the columnar format, such kind of systems can be able to call it as a data warehouse. No, right? What is the meaning of data warehouse? Is nothing but collection of data from the different types of the sources, and we are converting the data into the organized format for the purpose of doing analysis to take the decisions, and that is the definition of the data warehouse. Okay, don't assume that whenever we are going to maintain the data in the columnar format, that kind of system we can able to call it as a data warehouse. Are we giving that kind of definition here? No, right? For example, in the on-premise systems, and earlier we are maintaining all the data warehouses in the Teradata, but coming to Teradata, what kind of data we are maintaining? Row format. We are not maintaining the columnar format, but this is the kind of the system we are maintaining in the on-premise for the purpose of maintaining your data warehouse projects or data warehouse systems. Okay. Now, if you are going to compare the Teradata and BigQuery, where we can able to see the best performance? In the BigQuery, because in the BigQuery, they are going to maintain data in the columnar format, but coming to Teradata, they are going to maintain data in the row format. But coming to here, what we are saying, in the Teradata, we are building data warehouse system. In the BigQuery also, we are going to build the data warehouse systems. And don't assume that wherever we are going to maintain the data in the columnar format, that is not falling under the data warehouse. That is not the definition of the data warehouse. And what is the definition of data warehouse? Whenever we are going to get the data from the multiple sources, when we are converting the data into organized format for the purpose of doing the analysis to take the decision, that kind of system we can able to call it as a data warehouse system. Okay. Based on this, we can able to give the answer for your question yourself.
Okay, sir. Thank you.
It's clear, right? Okay.
Yeah.
Any other questions so far? Yeah.
Sir, actually, like in Teradata, we are using the parallel processing, right?
Yes,
Storing
correct.
data.
In the
And
BigQuery also we are going to use the parallel
data.
processing. Yes.
That is also distributed thing.
Yes.
Yes, sir. So the thing is, previously we are doing on premises the parallel process with the distributed one. Okay.
Yes.
So in here, but we are using only columnar. If you want to fetch more than one row, like not total.
1 second, just 1 second. In the BigQuery, are we doing any distributed operations or not? If you remember, yesterday we discussed, Randy. Coming to here, for the purpose of storing, we are using the Colossus.
Distributed. in the Colossus. Correct.
Mm.
Correct.
Mm.
So here there also we are using some like storage area. So there also we are using the distributed process. Okay.
Yeah.
But as you told that total column, it will be very easy to fetch in other systems. Okay.
Mhm.
Here also, if you want to fetch more than one column, two columns,
Mhm.
so it will take time as well, right?
Yeah, it will
So
see.
what is the use
See,
here?
compared to row format data, in the columnar format data, it will take time. But whether it is taking the more amount of time or less amount of time. See, I am comparing with the row format data. And when we are comparing with the row format data, in the columnar format data, if you want to fetch the complete row, it will take time. Okay. When I'm saying it will take time, don't assume that it will take the minutes of time or it is going to take the 10 minutes or 15 minutes only. It is fast, but compared to row format,
It's not
it is a bit slow. That is one thing. Okay. Second thing, if you remember, as part of discussion about BigQuery, I given one statement in the definition. In the BigQuery, also what is going to happen? It is going to deal with the petabytes of the data within the seconds. Okay.
Yeah.
And one more thing, as part of BigQuery or as part of the data warehousing projects, generally we are going to write the queries by using the star operator, or we are going to write the query by applying the joins and by applying the aggregations most of the time.
Yeah, particular column only, not the
Most of the time we are going to deal with the data warehouse system by depending on the particular columns, and by considering all those things, I'm going to say BigQuery is best for the purpose of dealing with our data warehouse system. Coming to your point, I only told you earlier, right? Whenever you are going to deal with the complete row or all the columns, then what I'm saying, row format is best, because in the row format you can able to fetch all the records very fastly when you are dealing with all the columns. But in the data warehousing process, as I told you, we are going to deal with the specific columns and we are going to perform the kind of shuffling operations or aggregate operations on top of those columns. And in such kind of system or in such kind of situation, our columnar format is going to provide the best performance compared to the row format databases. Is it clear?
Okay. Yeah.
Okay, thank you. Any other questions still?
Sir, can we assume like it's a drawback for BigQuery for loading operations?
See, again, for loading also same thing, Andy. So actually here we are discussing about row format and columnar format comparison. When we are comparing, what I'm saying here, in the row format, your data loading is fast, but coming to columnar format, data loading is slow. But
Yes.
within the BigQuery, they are maintaining the Dremel architecture, they are maintaining the Colossus, they are maintaining the Jupyter network. All these are the legacy technologies of the Google, and because of using all those technologies, even in the BigQuery, if you are going to maintain the columnar format data, our data loading operations are happening very fastly. Earlier, what we discussed is just I compared the row format and the columnar format for your understanding. As part of discussing about row format and columnar format, I told you in the row format, data loading is very fast, and columnar format data loading is it's slow, not very slow, it's a slow operation. But tell me, when we are going to discuss about the BigQuery, within the BigQuery, what we are using? We are using the columnar format data, but other than columnar format, as we discussed yesterday, within the BigQuery, what kind of architecture we are using? We are using the kind of a Dremel architecture, we are using the Jupyter as a network, and we are using the Colossus as a storage area. All these are nothing but kind of legacy softwares which we are using in the Google side. Because of using all these kind of technologies, and even it is going to store the data in the columnar format, we are seeing the best performance as part of loading the data also. Okay, don't get the confusion here. I'm only giving the two statements, Andy. I am saying that BigQuery is good for data loading operations also. And earlier I only given the statement compared to row format and columnar format, loading operations are slow in columnar format data. Okay, so here I'm only giving the two statements. Compared to row format and columnar format data, loading operations are slow where in the columnar format data. And coming to BigQuery, what kind of data we are maintaining? As I told you, in the BigQuery we are going to maintain the columnar format data. Actually, what need to happen? In the BigQuery, your data loading operation should become as a slow, but because of maintaining our Dremel architecture, because of maintaining the Jupyter network and all these things, and in the BigQuery, we are seeing the good performance as part of our data loading operations also. Here, try to understand what is the difference between the row format and the columnar format. By considering this, don't think that BigQuery is going to give the low performance as part of loading the data. BigQuery is providing the good performance as part of loading the data also, because of, just I will add the statement also here, because of Dremel architecture, which uses Dremel execution engine and Jupyter Network, and Colossus databases. Is it clear or still any confusion?
No, fine.
Here I am comparing row format data with the columnar format data, and just for the explanation I said that as part of row format what all are the advantages, what all are the disadvantages, as part of columnar format what all are the advantages and what all are the disadvantages. First we try to understand about all this kind of information. There we discussed about advantages and disadvantages only. Now coming back to BigQuery, it is going to maintain the data in the columnar format, but even though what is going to happen, our data loading operations are very fast because of our Dremel architecture, because of using the Dremel execution engine and Jupyter Network and Colossus as a data store. Here we can able to say as part of our BigQuery, data loading operations are fast. At the same time, our data retrieval operations also fast as part of our BigQuery data warehouse system. Okay. Any other questions so far? Okay. If no questions, I will ask one question only. What is the difference between row format data and columnar format data? Difference between row format data and columnar format data. Try to give the answer.
While loading the data, the row format is fast compared to columnar.
Yeah, no, see, those are the advantages and disadvantages. And so whenever anyone is asking the question differences, so what we can able to say, just take this example. That's the reason only I given this whole example only. So as part of row format data, what is happening here? Your rows are appending one row to other row only, which is nothing but first it is taking the first row. After the end of the last column, it is going to add the second row. After end of the last column, again it is going to add the third row. After end of the last column, it is going to add the fourth row. So this is the way your data is storing as part of your row format data. Because of this reason, whenever you want to deal with any specific column, it is taking the more amount of time because it need to read all the rows, and from all the rows it need to take the data for the particular column. For that reason, your fetching operation is very slow as part of our row format data. But coming to columnar format data, what is happening here? Your data is loading, all the column values are storing together, all EAD values are storing together, all the ename values are storing together, all the DID values are storing together, and all the salary values are storing together. So this is the way first difference we can able to say, and here this is the data storing for each and every row appending one by one. But coming to here, all the column values are storing together. That is the main difference between the row format data and the columnar format data. After that, we can able to specify in the columnar format data, loading is providing the bad performance, but fetching is providing the best performance. But coming to row format data, loading is fast, but fetching a particular column is a slow operation. After giving this statement, then you can able to add the advantages and disadvantages as part of discussing about our differences. Okay. So this is all about our what is meant by columnar format data only. Still, if anyone is having any other questions, please ask me on the columnar format data. Okay, one last question. In the BigQuery, what type of data it is storing in the internal system? Row format or columnar format?
Columnar format.
Columnar format only. So that is a very important thing you have to remember. For that reason only we are spending this much of time to understand what is the difference between the row format and columnar format. We are discussing about the BigQuery. Within the BigQuery, it is storing all the data in the columnar format. That's the reason we are trying to understand what is the difference between the row format data and columnar format data. Okay.
Sir, one question, sir.
Yeah, please.
This is related to the privacy rules, sir. While storing or while doing this ingestion process inside the BigQuery, are we going to take care of any special rules for privacy, sir?
Yeah, for privacy, we are going to apply the kind of the masking operations, and we are going to apply the kind of the PI operations. And again, that's a completely separate topic. How that topic is related to the row level format and columnar format? No. Do you think any relationship between both the things?
Yeah, at a column level, let's say I'm storing employee ID.
Okay.
According to privacy rules, related data should not be visible in it. Like employee ID 1, say salary some 100.
Okay.
So if these two things are visible together, then we are violating the privacy rule.
No, it's not like that. So that is not it's not like that. Now see, for example, this is the data we are storing. Now, for example, here I am going to store one more column called as, for example, mobile number. Just assume that I am going to store one more column as a mobile number. Here we are having all the people mobile numbers. Now tell me, out of all these columns, which is the privacy column? Which is the privacy
Only
column?
mobile number.
We can able to say mobile number column is a kind of a privacy column. Now when we are giving this data to the other people, we need to hide this column or we need to show these columns to the other people. Actually, if you ask me, we need to hide this column. Indirectly, this we can able to call it as a PI column, which is nothing but this column is having the personal information, which is nothing but we need to hide this column. Actually, in the BigQuery, we are having the feature to hide the columns or to mask the columns. By depending on our requirement, we can able to hide the columns or we can able to mask the columns. And now, for example, if we are storing the same data in the row format also, for example, after the salary, here I'm having the mobile number column. And here also after salary, we are having mobile number, here also mobile number, here also mobile number. In the row format data also, we can able to hide this column by depending on our requirement. And don't assume that we are making all the columns together for the purpose of the security reason. That is not a correct statement. If you want to apply any security on any particular column, here we are calling such kind of columns are nothing but the PI columns. And to maintain the PI columns, we are having some other kind of features in the BigQuery, or in the row format data also, we are having other kind of features to maintain the PI columns. Again, all these PI columns is a kind of a separate topic that we are going to discuss in the coming classes. But for now, is it clear?
Yeah, it is clear. So storage wise, it is going to be logically like that only.
Yes, exactly.
But when you discuss privacy, you will tell that.
Yes,
but
exactly.
Storage wise, it is going to be like the
same way.
the
See,
same
as
way.
part of discussion storage, either in the column format or row format, and whatever we discuss, it is following in the same way. But when you want to apply the security on top of any specific columns, like mobile number, or for example, I'm having one more column as a address. Now tell me, address is a personal column, or it can be display address for all the customers to all the people. It is also kind of a personal column. And or for example, in my table, I'm having one more column as a saving amount. Now tell me, for all the customers, we are maintaining same amount, saving amount in one table. Can we display this data to all the users in the market? No, right? Indirectly, all these are falling under the PI columns, which are nothing but the personal columns. And when we are giving this table to the other people, we need to hide all these kind of columns. How we are going to hide the column, that is comes under the PI topic. And during discussing about that topic, I will tell you how we can able to hide all these columns from the table. But for now, we are discussing about how we are going to store the data in the columnar format, how we are storing the data as part of our row format data.
Okay, storage level, it is now clear, sir. My doubt is clear.
Okay, very good, Andy. Any other questions still? Okay, if no questions, well and good. Now we'll try to understand. In previous classes, we discussed about BigQuery operations by using console. Second one we discussed about by using console with SQL commands. Now we can able to perform the same operations by using the Cloud SDK, or we can able to perform the same operations by using our Cloud Shell. And I think yesterday at the end of the section, we discussed about the statement. Cloud SDK and Cloud Shell, both are same or both are different? Both are same only. Now, whatever the operations we performed by using the BigQuery console, or whatever the operations we performed by using the BigQuery console with the help of the SQL queries, and same operations we can able to perform with the help of the Cloud SDK, or by using the Cloud SDK Cloud Shell. We can able to perform the same operations by using either Cloud SDK or Cloud Shell. If you remember earlier, multiple times we discussed about the Cloud SDK. Today we'll try to perform the same operations with the help of the Cloud Shell. Okay. Now you try to give the answer. How to open the Cloud Shell? First, we need to open our console. We need to open the console. How to open the console? Don't ask me the question how to open the console only, because from last 20 days onwards, we are discussing about the GCP platform. Just we have to give the console.cloud.google.com. Once we are given the console.cloud.google.com, it is asking your username and password. Once you are going to give the username and password, then automatically you can able to open the GCP console. Now, once you are going to open the GCP console, here how I need to open the Cloud Shell. How to open?
Right side,
The search bar, there is an icon.
In the right side top or up beside the search bar, here we can able to see option called as a Cloud Shell, and just click on that. Click on the Cloud Shell. So once we click on the Cloud Shell, in the bottom, it is trying to activate the Cloud Shell. It will take 10 seconds or 20 seconds only. Okay. So after some time, it is going to give the window like this on the bottom side of your browser. Here you can able to get the Cloud Shell like this. Now, if you want to maximize this Cloud Shell, whatever the Cloud Shell open in the bottom of the screen, if you want to maximize this, what we can do here is we need to click on this arrow. Okay, or for some people might be it is asking you want to authorize or not only, please click on the authorize. If it is asking any authorization, click on authorize. Okay, after open the window like this, if you want to maximize, what we can do here, just we need to click on this arrow in the right side. In the right side, you can able to see one arrow called as a open in the new window. Just click on that. Okay. So once you click on this, what is happening here? Whatever the Cloud Shell we discussed, Randy, same Cloud Shell is going to open in the new browser. So here now we are having the BigQuery window. Sorry, not this. Yeah. We are having the BigQuery window. At the same time, in parallel, it will open the one more window for our Cloud Shell only. So if you want to open the Cloud Shell, just we need to click on the arrow symbol. Once you click on the arrow symbol, it is going to open the window like this. Might be your windows are in the black color. My window is in the white color. What's the reason? It's very simple. Just I change the settings only. Just you need to go to click on the terminal settings. Here, by depending on your requirement, you can able to change the text size, or you can able to change the color themes by depending on your convenience. Just for the visual purpose, what I did here, I given it as a white color. So for that reason, you can able to see my window in the white color. Okay. Now tell me, if you want to initialize a session, what we can do here? I want to initialize the Cloud Shell. What we need to do?
Cloud init.
G Cloud init.
We need to give it as a G Cloud init, and which is nothing but G Cloud init. Already, if you did the init operation, no need to perform that operation one more time. But if you want to perform that operation, we have to give it as a G Cloud init. Okay. Now, for example, I want to see all the list of the buckets in the Google Cloud Storage. What is the command we have to use? I want to see the list of the buckets in the Google Cloud Storage.
G Cloud
Need
LS.
to give GS LS. Just give this. Once we are going to give this, okay, it is asking authorize now. Okay, once I given the GS util LS, it need to display all the buckets which are available in the Google Cloud Storage. In my account, I'm having the only one bucket. That's the reason it is displaying that information. Now, in the same way, my requirement is in the BigQuery, whatever the databases we created, I want to display those databases only. Already in the BigQuery, we created some databases. I want to see the list of the databases from the Cloud Shell. So what we can do here is just we can give it as a BQ. BQ is nothing but BigQuery only. If you want to perform any operations on the GCS or Google Cloud Storage, we are using what? GS util. If you want to perform any kind of operations on the BigQuery, then we need to give the command called as a BQ. After that, just give it as a LS. BQ space LS. Now see how many databases I'm having. I'm having the two databases only. One is the sample Qt and other one is the sample Qt console. Just we'll go to the BigQuery window. Okay, here see in the BigQuery window, what are the databases we are having? We are having the sample Qt and also we are having the sample Qt console only. That's the reason if I'm going to give the query called as BQ space LS, what is happening? You can able to see all the list of the databases which are present in your BigQuery automatically from the Cloud Shell. Okay, from the Cloud Shell, if you want to see the list of the databases which are available, we are going to give the command called as a BQ space LS. Okay, now for example, my requirement is I want to create the database from the Cloud Shell. For example, from the BigQuery console, if you want to create the database, what we can do, Andy? What we can do? Beside the project, just click on these three dots, and after that, click on the create data set. With that, you can able to create the database by depending on your requirement from the console. But now my requirement is I want to create the database from the Cloud Shell. Whenever we are having that requirement, what is the command we need to start? We need to give say BQ. After that, you need to create a database. So for that, we have to give it as a MK and MK is nothing but make a data set. After that, we need to give the argument called as a -d. Then we need to specify the name of the database. I'm giving, for example, sample one SDK. So just for my understanding, I'm given the name like this: BQ space MK space -D space sample one SDK. This is the command I'm using, and after that, just click on enter. See what happened? Data set is successfully created. Now my requirement is, after creation of the database, I want to see the list of the databases, whether this database created or not. What is the command we can able to give?
BQ -.
Again, give the same command, BQ space ls. See what is happening? Now you can able to see one more database called as a sample one SDK, and this is the way simply we can able to create the databases by depending on our requirement. Okay, but tell me, in our data, in our console side, by using the commands, if you want to create the database, what we did in the console, by using SQL queries,
Create schema.
if you want to create database, what is the query we given?
Create schema.
Create database or create schema?
Schema.
Database name. Create schema database name. For example, here I'm giving database name as a sample2 SDK. Okay, so actually this is the query we can able to run if you want to create the database from the console by using the SQL query only. But my requirement is, I want to run the same query from the cloud SDK or cloud shell. I want to run the SQL query. What we can do? Very simple. If you want to run the SQL query, what we can do here is, again we are going to give the same BQ, and after that we are going to specify one more keyword called as a query, because I want to run the query as per my requirement. That's the reason here I'm giving it as a BQ space query space. Then within the single quote we can able to pass any kind of SQL query, and here I'm giving the query called as create schema. I'm giving my schema name is, for example, sample2 SDK. So what I'm doing here, I'm giving it as a BQ query. Then I'm giving in the single quotes create schema sample2 SDK. This is the one I'm giving for the purpose of creation of the schema. In the previous step, what we did, directly we used the BQ command. We given it as a BQ MK-D sample1 SDK, and but in this example, I want to create the database by using the SQL query from the cloud shell. That's the reason here I'm using the keyword called as a BQ space query space. I am given the query within the single quote. After that, click on enter. Just 1 second. Okay. Now see, when we ran this query, what is happening here? It is given the error, encounter some kind of issue as part of create. And here what they are mentioning, and they are mentioning that use the standard SQL. Okay. So because of using the standard SQL internally, it is giving some kind of issue. And now see here, to avoid this issue, what we can do is, we are going to use this argument. So what is the argument we are going to use here? We are going to use the argument called as a use legacy SQL. This should be false only, because as part of running this query here, as part of running this query by using the BigQuery, what is happening here? It is trying to use the legacy SQL, but because of that reason, what is happening here? It is given the error as part of running this query. Now you don't want to use the legacy SQL. You want to use the standard SQL as part of running this query to perform that operation. What we have to do here? Just we need to add this argument, which is nothing but we are going to give it as BQ query. After that, we are giving this argument. For this argument, what I'm giving here, I'm giving it as a false, which is nothing but I don't want to use the legacy SQL. After that, we are giving create schema sample2 SDK. So it's very simple, and whenever you want to run the queries from the cloud shell, then what we can do here, just we need to give the keyword called as a BQ space query. At the same time, if you want to run the queries, what we have to do here, we need to give it as a use legacy SQL is equal to false. This is the one extra argument we are adding here. After that, within the single code, you can able to pass your complete query. Now this is the query we are writing. Now just try to run this query. Now see what is happening here. Your table has been created. above and below we are using the same kind of command, and the only thing is nothing but in the above query we are not using the argument called as a use legacy SQL is equal to false. Whenever you want to run any kind of SQL query, what we have to do here? We have to add it as a use legacy SQL is equal to false. By adding this argument, what we can do here? You can able to run any kind of SQL queries by depending on your requirement. Okay. Now, for example, my requirement is I want to create the table. If you want to create the table, what is the query actually we are preparing? Create. We have to give the table name. For example, we are giving the table name as a database name dot table name. After that, we need to give the column names. Okay, now this is the query we need to prepare if you want to create the tables. And now my requirement is I don't want to run this query from the console. I want to run this query from the Cloud Shell. Now you tell me what we have to do. This is the query I want to run. Now, as part of running this query, I don't want to run this query from the console window. I want to run this query on the Cloud Shell. So what we need to do in this query? That's what we have to do.
BigQuery.
We need to add BigQuery space. This entire query we need to pass within the single quote. That's it. Or we need to do any other operation.
Use legacy underscore.
We have to give this also, because whenever we are given the BQ query and we have to give this operation also. BQ space query space, just give it as a use legacy SQL is equal to false, and our complete query is same. Only thing is nothing but we are giving this query within the single code. Other than the query, before the query, what we are adding? We are adding it as a BQ query, and we are giving it as a hyphen use legacy SQL is equal to false. Okay. Now, for example, after creation of this table, my requirement is I want to add 2 columns to this table. For example, I want to add ID1 column and ID2 column. Now you tell me from the console, if you want to add the columns, and what is the query we need to prepare? From the console, if you want to add the columns, what's the query we need to prepare? Alter table. Our table name is nothing but we need to give it as a database name dot table name. After that, add column
Data type.
ID1 integer. This is the first column. Second column, add column ID2 integer. Actually, this is the query we need to run from the console only. But my requirement is I want to run this query from the Cloud Shell. Then what we have to do?
BQ query.
Query. Just we can able to take it. Before the query, what we have to add?
BQ query.
BQ query.
use
After that,
use
we need to
underscore
give
legacy.
use underscore legacy SQL is equal to false, and we need to pass this entire query within the single quote. That's it. So this is the way whatever the queries we discussed as part of our previous classes from the console, and the same queries you can able to run it one more time. But before running those queries, what we have to do here? We need to pass the complete query within the single code. Other than that, before this query, just we need to add the BQ space query space hyphen use underscore legacy underscore SQL is equal to false, and with that you can able to trigger any kind of SQL queries by depending on your requirement. For example, I want to see the data from the table. What the query we need to prepare? See the data. Select star from database name dot table name. Now I want to run this query from the Cloud Shell. What we can do?
Same BQ query.
Same thing. We need to copy paste again one more time. BQ query hyphen use legacy SQL is equal to false. After that, pass the query within the single code. Now tell me, is it simple or complex? Very simple, and whatever the queries we discussed from the console, same queries you can able to run with the help of the BQ query. Now by using the BQ query, you can able to perform all these operations in the very easy way. Okay. Yeah, someone is trying to ask the question. Please ask the question.
Sir, actually by using API like writing Python code, all these things good by using this BigQuery. Okay, fine.
Yeah.
But do we have any environment like SQL directly firing these queries?
Yeah, actually we are having the Toad only. So with the help of the Toad, what we can do here is we can able to connect to the, so those kind of tools we can able to call it
It's
as
a third-party tool.
third-party tools.
Yeah,
Okay.
okay.
By using the third-party tools, we can connect to BigQuery
BigQuery.
database.
But not
But-
yes, this by using this putty or like a CMD command.
No, can you please repeat that?
No, can't we connect like a normal MySQL like command line form?
No, actually here in the Cloud Shell, whatever you're doing, you're doing that from the command prompt only, right? I didn't get your question. Can you please repeat?
No. We are using the command prompt, but we need to add all those things like BigQuery, and we need to use this legacy all those things. Instead of that, don't we have like BigQuery SQL command.
Oh, you are asking that directly. I want to run these queries
Yes,
like
yes,
this. I
yeah.
don't want to use
Yeah.
all the BigQuery and everything. Yeah, we don't have anything, Andy.
Okay, sir. That's it.
Okay.
Yeah.
Yeah. So from the Cloud Shell or from the Cloud SDK or from the other type of command prompts, we can able to run all these things. But if you want to perform these operations, we have to run all these kind of prefixes. By adding the prefixes only, you can able to trigger all these kind of queries.
Okay, sir.
Okay. Yeah. Any other questions so far?
Yes, actually, I want to know is like Cloud Shell is opening and giving the some 5 GB of data for running this all Cloud Shell commands. So, is it possible to connect a different machine like our 1-2 machines or anyone is there in
Can you
real
repeat?
time?
No, can you repeat the question one more time? Sorry.
Cloud Shell is there for we have to connect of GCP resources in that, but in a different environment, so maybe its a process is slow in Cloud Shell. So it is possible to connect a different machine to this Cloud Shell.
Different machine to Cloud Shell. Tell me here, as part of Cloud Shell, are we connecting to any machines? We are
No.
not connecting to no machines, Andy. We are, see, whatever the account you created, you are accessing that account by using your Cloud Shell. Don't think that with the help of the Cloud Shell, we are accessing on the machines, Andy. We are not accessing any machines here.
Okay.
Hope you understood. Now, if you are going to work in the real time, what will happen? They are going to provide one account to you, or they are going to provide the credentials for one of the accounts. By using that, what we are going to do, we are going to open the Cloud Shell. With the help of the Cloud Shell, just you are connecting to the GCP services. Okay, you are not connecting to any specific machines in the GCP.
Okay, fine.
Okay, yeah. Any other questions? Okay, if no questions, Sandy, just for the simplification, already I have written all the commands here. Okay, just I will walk through all these commands one time only. So after that, if you want, you can able to perform the practice as part of after completion of the classes. Now see here, from here. Now see, what is the first query? And don't think that I typed everything and I'm explaining everything very fastly, Andy, because all these queries already we discussed as part of the previous classes. For every query, just what we are adding? We are adding the BQ query. Okay. Now, for example, I will replace all these BQ queries here. Replace all. Now see what we are having. We are having normal queries or we are having any different queries. Select, alter, drop, update, everything, Andy. Just what we are doing here, we are performing the same operations just by adding the BQ query, because in the real time, you are not going to get the console access. You need to perform all these operations from the Cloud Shell. That's the reason, just to get the hands-on practice, we are doing the same operation, but we are doing the same operations from the Cloud Shell. Okay. Now, if you see the first query, what is the purpose of the first query here? This is for creation of the schema. If you want to create the schema, I'm giving it as a create schema. I'm giving the schema name, but please try to give the schema name by using the project name and the project name dot schema name. For example, in your account, you are having the multiple projects. Then what will happen? It will get the confusion in which project you need to create. And one more thing, as part of Cloud Shell, to what we are connecting? As part of Cloud Shell, what we are doing?
We are connecting.
First step is we are doing the initialization. As part of initialization, we are connecting to a specific project only. First one, it is asking for which Gmail ID you want to connect. After that, it is asking to which project you want to connect. After doing all those operations, if you don't want, you can able to skip the project name. But what is the best practice? Under the project only, we are creating our databases, right? For that reason, best practice is at any point of time, whenever we are going to give the schema name, better to give it as a project name dot database name. That is the best practice we have to follow as part of our real-time projects also. Okay, so I'm giving it as a create schema project name dot our database name only. But when you are doing the practice, what you have to change? You need to change the project name. Okay, because in your system might be you're having the different project name. You need to give your project name. If you want, you need to change your database name also by depending on your convenience. And here in my system, I'm giving it as a database project name as a Qt sample and database name as a sample underscore SDK. Now, after creation of the database, what is the next step? I need to create the table. If you want to create the table, what is the query we are using generally? Create table, if not exist, project name dot database name dot table name. Then we are given the complete structure. Same query here also we are using. Only thing is nothing but we need to pass this entire query in the single quote or double quote. After that, before this query, we have to give it as a BQ query hyphen use legacy SQL is equal to false. After creation of the table, what is the next step? For example, if it is an empty table, we need to insert the data manually. If you want to insert the data manually, what we have to do here? we need to give the query called as a insert query, and whatever the insert query we need to prepare, we have to give the complete query. That complete query we are passing in the course again, and before that we have to give the query called as a BQ query. And after that, if you want to see the data, select star from the table. Before this entire query, again we are giving it as a BQ query, and after that, if you want to alter the table, we are given the alter command. Just here I'm adding the only one column, which is nothing but ID1 column. We are given the data type as an integer, and this is the query you have to prepare. Before this query, again we are giving it as a BQ query. In the same way, if you want to see the data, select star from the table. And next one, if you want to drop the column, we are giving alter table name drop column, and by using this query we can able to drop the column. But if you want to run this query from the Cloud Shell, just we are adding it as a BQ query before that. With that, you can able to run the same query from the Cloud Shell. In the same way, if you want to drop the table, what we have to do? Drop table name. By giving this query, we can able to drop the table normally. But if you want to run the same query from the Cloud Shell, write the same query in the double quote. But before that, just give it as a BQ query, and by using that, you can able to drop the table. Same way, you can able to perform the update operations. You can able to perform the select operations. You can able to perform the delete operations, and you can able to alter the table by adding the constraints, or we can able to rename the table, or we can able to drop the primary key. All these kind of operations we can able to perform from the Cloud Shell by using all these options. Okay. Any questions on all these queries, please ask me. I don't want to spend much time on these things only, because already we discussed about all these queries. At the same time, I explained for 1 or 2 queries how we can able to run these queries from the Cloud Shell. After completion of this class, I will send this document to you. Please run all these queries from the Cloud Shell. With that, you will get some understanding how we can able to run the BQ query commands by using the Cloud Shell. Is it clear? Now, in the same way, if you want to create the backup tables, how we need to create the backup tables in the MySQL? How many approaches we discussed? We discussed about the 3 different approaches, and first one, only copy the structure. Second one, copy the structure plus data. Like that, we discussed about the different approaches, and same approaches. If you want, you can try it on the BigQuery also. For that, here I given the queries. If you see, tell me if I'm going to run this query, what will happen? This query, create table name like source table name. If I'm going to run this query, what will happen?
Like only
it will
structure.
copy the structure, or it will copy the
only.
structure plus data.
Only structure.
Only
It will
structure.
copy only the structure, because if I'm given the like operator, it is going to copy only the structure of the table. Now, after copying the structure, you want to copy the data. Then what we have to do?
Insert.
We need to give the insert with the select statement, and insert into the table, select star from the table. With that, what will happen? You can able to copy data from the one table to other table. This is the one way of creation of the backup table. What is the other approach?
Select star from.
Directly, we can able to give it as a create table name as select star from the table. By using this query also, what we can do here, you can able to create the backup table. But if I'm going to run this query, what is going to happen?
Structure and data.
It will copy the structure or data or both.
Both are
it is going to copy the structure plus data automatically to your backup table. But instead of running these queries from the BigQuery console, and what we are doing here, we are running all these queries from the BigQuery. Sorry, we are running all these queries from the Cloud Shell. If you want to run these queries, what we have to do before this query? Just we are adding the statement. With that, you can able to run all these queries from the Cloud Shell by depending on our requirement. Okay. After completion of the class, I will share all these queries to you. Please perform all these queries, or please run all these queries on the Cloud Shell. Okay. Now, one more important thing, Andy. Whatever SQL queries we are discussing in MySQL or in database concepts classes, can we run all these queries in BigQuery or not? Answer is yes or no. Simple answer is yes, and actually in some of the issues they are conducting BigQuery trainings. As part of BigQuery trainings, they will discuss about the BigQuery concepts, and also they are going to discuss about the same database concepts whatever we're discussing in the 11:45 and 2:30 classes. And indirectly what I'm trying to say here is, whatever the practice you are doing by using the MySQL, run the same queries on top of the BigQuery. Then what is the advantage? One thing, you can understand how to run queries in BigQuery. Second thing, you can get, or you can do practice multiple times by using same SQL queries. So this will be helpful for you to do the revision, and this will be helpful to do practice one more time. At the same time, you will get the habituation how we can able to run the queries on top of your BigQuery ID. And when you are doing this operation, here my suggestion is do these operations from the BigQuery console and do the same operations from the BigQuery Cloud Shell. With this, total how many times you are doing the practice on our database concepts only? One time you are doing from the MySQL. Second time you are running the same kind of queries, same kind of concepts from the BigQuery console. Third time you are doing the same operations from the BigQuery Cloud Shell also. And with that, you are indirectly doing the practice for the all SQL queries 3 to 4 number of times only. With that, you can able to get the good knowledge on top of your database concepts. Okay. And one more question: if you are going to work in the real-time projects, if we are going to use BigQuery, most of the time, what operations we are going to perform in any cases? Most of the time, what operations we are going to perform? We are going to write queries, queries. So most of the time you are going to work on the queries only, and we are going to perform the loading operations also, that I will discuss with you separately. But most of your time, what is going to happen? You need to prepare the queries only, even if you are going to use the BigQuery also. And for that reason, as part of MySQL, whatever the commands we discussed, please try to run all those commands, all those topics with the help of the BigQuery console and with the help of the BigQuery Cloud Shell. And with that, automatically you can able to get the perfect knowledge on the BigQuery SQL also. And as part of interviews also, in interviews, they will ask questions on BigQuery. After asking the questions on the BigQuery, immediately they will start asking the questions on SQL queries. Okay. Now tell me, for BQ and MySQL, do we have different SQL queries, or we are going to have the most of the same SQL queries? We are going to have the most of the same SQL queries only, but in our brain, we are thinking that BQ is the separate one, we are having the separate queries, and MySQL is different one, and we are having the separate queries. And don't think like that only. Whatever the queries we are discussing, same queries are going to applicable for the BigQuery also, or I can able to say like this. In the previous classes already we discussed about this statement. In the database concepts, we are discussing about SQL. Same SQL we are going to see in the BigQuery. Same SQLs we are going to see in the Spark SQL. Same SQL we are going to see in the Bigtable. Like that, multiple places we are going to see the similar kind of SQL queries. And now, for example, in the GCP, we are having the BigQuery. Okay. Now, if you are going to the AWS, and in the AWS, what we are having? Any cases?
Redshift.
We are having Redshift. Now tell me in the Redshift also what operations we are going to perform. We are going to perform the same SQL operations. And I'm not saying that we are doing only SQL operations in the BigQuery and Redshift only. We are doing some other operations also. But most of the time we are spending on writing the SQL queries only as part of your BigQuery or as part of your Redshift. Now, for example, in the market, we are having one more database called as a Snowflake. Any cases in the Snowflake also what we will do? We are going to perform the same SQL operations. Indirectly, I can able to say, once you are going to get the perfect knowledge on top of the SQL queries, and you yourself can able to say you are having 60% of knowledge on Redshift. And you can able to say you are having 60% of knowledge on Snowflake, because wherever you go only, so in the Redshift or Snowflake or BigQuery, everywhere what we are doing most of the time, we are going to write the SQL queries only. But what about the remaining 40%? Remaining 40%, we need to understand how we need to access the console, or how we need to load the data from the different types of the files. And so far we discussed about how to create the empty table, how to create the GCS table, and how to create the drive table. So like this, we discussed about some of the topics. And but if you are going to work in the real time, we are going to load the data from the ORC files to tables, and we are going to load the data from the Parquet files to the tables, and we are going to orchestrate all these loading operations. What is the meaning of orchestration at high level? We are going to schedule all the jobs, and job 1 created, job 2 created, job 3 created. Job 1 every day morning at 10 AM I want to run. Job 2 every day morning at 11 AM I want to run. So that we can able to call it as a orchestration. So these are the topics will fall under the remaining 40%, and or we can able to say architecture. Here we discuss about architecture of the BigQuery, but do you know architecture of Redshift? No. Do you know architecture of the Snowflake? No. Okay. Now indirectly here we are saying that With the help of SQL queries, we can able to say, you can able to say you are having knowledge of 60% of Redshift and 60% of Snowflake. Remaining 40% nothing but we need to understand what is the architecture of all these things and what is the WRC file. By using WRC file, how to load the data. By using Parquet file, how to load the data. By using JSON file, how to load the data. Now in the BigQuery so far, what we discussed? We discussed about by using the CSV file how to load the data. We discussed, Randy, but we haven't discussed about how to load the data by using the WRC file, how to load the data by using the Parquet file, how to load the data by using the JSON file. These topics we are going to cover as part of our tomorrow session. But why we are discussing all these things? Because SQL is going to play the very important role as part of our cloud data engineering. For that reason, please do the practice by using MySQL. Please do the same practice in the BigQuery. In the coming days, when we are going to discuss about the Spark SQL, and at that time, you can repeat the same database concepts again by using the Spark SQL. Like that, you can able to perform the practice on the SQL queries multiple times by using MySQL or BigQuery. In the coming days, we are going to use the Spark SQL. Okay. And one more last session, Andy. Whatever queries you are practicing, please copy, paste those queries into your notepad or Word. Anywhere, please store it. What's the reason? Next time, if you want to do the practice, what you can do? One operation, you can do the copy paste. Otherwise, if you want to recap whatever the practice you did previously, Andy, then what we can do, simply you can refer your notepad or you can refer the MS Word. And one more session here. Just give the heading as create. Please copy all the commands which are related to create. And after that, just give the, for example, logical operators. Coming to logical operators, whatever the queries you practice today, please copy paste all the queries. In the same way, for example, aggregate operations. Under the aggregate operations, whatever the queries you practice, please copy paste all the queries. Like that, if you are going to prepare one notepad yourself or one Word document yourself, what will happen? After 1 month or 2 months, if you want to recap everything, Andy, just you can able to open the document, and with that you can able to recap whatever the practice you completed. In the same way, whatever the tables you are creating, and can you please go on mute, whomever not talking, whatever data you are inserting, those queries also please copy and paste. What's the reason? For example, in future, in your laptop or in your desktop, only your MySQL is crashed. What you will do? You will reinstall the MySQL. Once we are going to reinstall the MySQL, what will happen? All your tables and database will gone only. Again, if you want to create the tables from the scratch, what will happen? It will take good amount of time. If you want to insert the data 10 records or 15 records, again, it will take some amount of time. Just for the purpose of saving all the time only, whatever the create commands, whatever the insert commands are, whatever the practice you are doing, please copy paste all those things into one notepad or one Word document. With that, you can able to recap all the things after 1 month or 2 months. Or whenever any crashes are going to happen on your MySQL software, then after completion of the reinstallation, by using this notepad, you can able to recreate the tables and you can able to reload the data on top of your tables. With that, you can able to perform the practice very easily. Okay. Yeah, I know I've taken 5 to 10 minutes of time to discuss all these things, Sunday. But my final intention, please perform the practice for all this. I will share this document after completion of the class. Please run all these queries from the Cloud Shell and run all these queries from the console also. With that, you can get the best practice on top of our BigQuery topics. Okay.
Sir,
Yeah, 1 second, Andy. Yeah. Any questions up to here? Okay, if no questions, online people or offline people, if no questions, you can leave for the day. And next class we are having at the 11:45. We'll connect at 11:45. Yeah, please ask the question if someone is trying to ask the question. Hello. Yeah, someone is trying to ask the question, right? Can you please ask the question now?
And sir, about the communication process.
Yeah, as I told, so 1 second, Andy. Yeah, as I informed you earlier, so from today onwards, our communication skills classes are going to start, Andy. It is from 10:30 to 11:30.
Okay.
Online or offline? Okay, so our admin team will send the message in the group only. So if it is online, they will share the link. If it is offline, you need to come to the classes and you need to attend in the offline classes. Our admin team will send the details in the group, Telegram group. Okay.